Hello and welcome to this video in which I go over an application of a linear function. So in this video I'll just be doing one example with several parts to it in which a linear function is applied to a real-world problem. And this is pulled from an intermediate algebra text so that you know the scope of the material. So let's get going. Okay, so my example is this. Let's read it. All right, the cost, which will be represented by the variable C, of renting a 12-foot moving truck for a day is $40. So it looks like the cost units is in dollars. Plus, on top of this $40, 35 cents or $0.35 times the number of miles driven. In other words, it costs you $40 to rent it for the day and an additional 35 cents for each mile you drove that day. And that's described here by this linear function. The linear function, c of x equals 0.35 times x plus 40, describes the cost, c, of driving the truck x miles, right? So x in here is the input, the independent variable, and x represents the number of miles driven that day, and c, the output, this 0.35x plus 40, c represents the cost of renting the truck for that day. Okay. So question 1, or part A, what is the domain of this linear function? Now remember, domain is the set of inputs, right? So this is the set of values I can replace x with in this expression, this function. Now normally, if I was given just the function without all the words around it, and I said, what's the domain of that function? C of x equals 0.35x plus 40. And I asked, what's the domain of that function? Normally I would say that the domain is all real numbers. I can plug in whatever I want for x. So there's no denominators that'll become 0 all of a sudden. So no even roots, no logarithms, no part of the expression that would end up giving me a non-real output. So normally I would say the domain is all real numbers, but as in all word problems, right, you have to think of the context. What is the meaning behind the problem? What is this problem discussing? We're talking about renting a truck. And driving it for so many miles. X represents a number of miles driven. All right. I'll write that again down here. X equals miles driven in that day. So it doesn't make a lot of sense to talk about, plugging in negative numbers for x. Can you drive negative miles? All right. So I'll put that in parentheses here. So negative inputs don't make sense in this context. All right. But anything other than that would make some sense. I could replace x with 0, and that just means I didn't drive the truck. I rented it but didn't drive it. I drove it 0 miles. And really any positive number after that, up to a certain point, but we're not going to get into too picky a detail like how fast the truck can go and how long you drove it in the day for. So yeah, you could drive 1,000,000 miles in a day if the thing, if this was on some other crazy planet where trucks could go super fast, and I don't know. All right, so I'm not going to put an upper limit on that. All I'm going to say is we can plug in any non-negative number here, right? When we're talking about miles driven, that's really all that makes sense. So for the in the context of this particular problem, I would say that the domain of this function c is, I can plug in any x I wish, right? Again, domain talks about the inputs. The input is the variable x here, such that, right, a little bar separating, then the conditions, right? I can plug in any x I want as long as, and I would say that as long as x is greater than or equal to 0, or you could actually write out the words as long as x is non-negative, right? And if you want to write that in interval notation, you can, right? The lowest value or the low end or the left endpoint of this interval would be 0, right? Nothing. I'm not plugging anything below 0, and there is no upper end, right? I'm talking about values all greater than 0, so I indicate that there's no upper value in the domain by putting infinity on the right endpoint. And I can plug in 0. I've decided to myself that 0 makes sense here, right? Driving 0 miles actually makes sense. So 0 is part of the domain, so to indicate that, I put the rectangular bracket on 0 to indicate that 0 actually is part of this set. And infinity is not a number, right? Infinity, negative infinity, those are not numbers. Those are concepts. Those are ideas. So those always get parentheses to indicate that, there is no number infinity. That is not actually part of the set. Great. Okay, so again, based on the context of the problem, I would say that we're only going to be plugging in non-negative mileages, right? Non-negative values of x. Wonderful. All right. So then part B, asked to determine the c-intercept. Notice, it's not x-intercept or y-intercept. My input is x. My output is c. So c is just like y normally, right? You're probably more used to x and y in an equation. And we're going to make a graph later with a horizontal axis and a vertical axis. And the horizontal axis is typically reserved for the independent variable or the input variable, which is x. And then the vertical axis, the one going up and down, will be reserved typically for the dependent variable or the output variable, which in this case is c. So when they talk about determining the c-intercept, this is like the y-intercept. Then, okay. The point on the vertical axis on this graph of this linear. All right, so we have c of x equals 0.35 times x plus 40. And if I'm trying to find the y-intercept, or in this case the c-intercept, being on the vertical axis means we're going to have an x-coordinate, an input of 0. All right. So we're going to let the input be 0 and see what the output is, what the value of c is. All right, so the value of c, just replacing x with 0 throughout the rule here, the value of c at 0, right, the value of c at x, the value of c at x, 0 here, is equal to, and then the other side, 0.35. How do we calculate the output? 0.35 times 0, right, replacing x with 0, plus 40. And I'm getting the value of c at 0 is 40. Right? Remember, this is 40. This is $40. Right? C is the cost of the rental. Right? So if I drive 0 miles, right? And I guess I could put that in as well. Right? This is 0 miles. Remember what x represents, right? A number of miles driven. So when the input is 0 miles, I have driven this truck 0 miles. The cost of driving no miles is still $40, right? That was mentioned. The cost of renting this moving truck for the day is $40 right up front, and then more money if you drive miles. Right? Okay, so the c-intercept then. Right? So the c-intercept would be this ordered pair. This point would be on the graph, and I'll make the graph later, where I have the independent variable, comma, value of the dependent input output, value of the dependent variable. So my x value, my input, is 0 miles, comma, and then the output is the $40. So I'm going to plot this point later on a graph, right? So this is the c-intercept of the graph of that linear function from the problem, 0, comma 40. Okay, great. Next problem. All right, we'll get to the graph later. Next question, part C. Same problem here. What is the rental cost if the truck is driven 80 miles? So the big question is, what is the rental cost? Now remember, rental cost is C, or C of X. And driven 80 miles, that's the X value, right? That's X equals 80 miles. Because remember what X means, right? X is the number of miles driven, and C is the rental cost. So this is basically asking this question, you know. You could also say this is asking the question, when X equals 80, right, when I've driven 80 miles, what is C of X? Right, this could be the same, this is the same exact question. All right. So we're trying to just plug in 80 then, right? So what is the value of C at 80? So I'm just going through the rule here for the function and plugging in 80 for my input, plugging in 80 wherever I see X. So the value of C, the cost at 80 miles, is equal to 0.35 times 80 and then plus 40, okay? And then 0.35 times 80. Now if you want to set up some multiplication there, 8 times 35 would be 240 plus 40 would be 280. This is just 35% of 80. This is 28. Or you could punch in a calculator if you want. I have no preference really. I mean, I'd like you to do things without a calculator, but you can get around it too. We use a calculator, right? It's 28.35 times 80, and then plus 40 makes 68. Remember, this is the cost of driving 80 miles. So C of 80 equals 68, and what that means in words, the answer to this question, the rental cost for driving 80 miles is $68. Remember, C is cost in dollars here. And this is how I would answer, right? I mean, you should answer all your word problems in complete sentences and put units on every number so that the numbers have meaning, right? Miles on 80, dollars on 68. Great. Additionally, too, this also gives us another piece of information. If you were to graph, so on the graph of C, which I'm going to make in a little bit, the point, 80 for the input, comma 68 for the output. That point will be on the graph of the function C, of this linear function, which we'll get to later. So now I have two ordered pairs. I have 2 points. One is that C intercept, right, 0, 40 there on the part B, and going through this, figuring out what the rental cost was after driving 80 miles, that gives me another point, this 8068. All right, next question, part D. So same problem, all right, keep the problem up here. So here's part D. All right, so how many miles was the truck driven if the rental cost is $85.50? Right, so again, reading through this, the question is about how many miles was the truck driven. Well, miles was the truck driven. That was X, right? X was the number of miles the truck drove. So we don't know X. They're saying how many X, right? What is the value of X? How many miles was the truck driven? If the rental cost is $85.50. So they're giving us the rental cost. That was the value of C. So C, or C of X, is $85.50. So another way I could answer this question is, you could also say this is another way to ask this question: for what values of X right? For what value of x is c of x, right? The cost at that x miles, the c of x equal to 85.50. They mean the same thing. So what you're really doing here is solving this equation, c of x equals 85.50. You're solving this for x, right? I'm trying to find an x, trying to find how many miles I would have to drive so that the rental costs would be $85.50. All right, so let's take a look at that equation. C of x, well, what is the value of c at x? That is this 0.35x plus 40, right? So this is 0.35 times x plus 40, all right, equals, and then the $85.50, 85.50 over here. And then we're solving this equation. Now this is an equation involving decimals. Very often people don't care for decimals, kind of like fractions. So one way around this, to get around using decimals in an equation, is to multiply by some power of 10, whether it be 10 or 100 or 1,000, right, or 1/10th, 100th, 1,000th, just 10 to some power on both sides to move the decimal points around. Now I notice here that if I want these decimals to be nice whole numbers instead, I'd need to move the decimal point to the right 2 places, right? And that'll also happen here. Now to move the decimal to the right 2 places, you need to multiply by 100, 1 with 2 zeros after it, right? To move the decimal place 2 places. So I'm going to do that. All right. So first I'll take 0.35x, plus 40, and we're going to take that entire side and multiply it by 100. And I do the same to the other side, right? Take 85.50, 85.5, and multiply that by 100 as well. Now the left side has multiple terms, right? There's 0.35x, there's 40, so I need to distribute there, and then the multiplication by 100, 100 times 0.35, again, just multiplying by 100 just moves the decimal place to the right 2 places. So this would be 35 times x plus, and then 40 times 100, move the decimal point is after the whole number, moves it right 2 places, makes that 4,000, right? 40 with 2 more zeros. And then on the other side, same thing, 85.50 times 100, move the decimal place to the right 2 places, would be 8,550. All right, now I have nice whole numbers involved in my equation. Okay, wonderful. And it's easy to solve now, right? It's a nice linear equation. I take away all the terms of the variable to one side and terms without the variable on the other. So 35x I'm going to keep on the left. Subtract this 4,000 from both sides, right? Get rid of the 4,000, giving me 35 times x equals, on the left equals, and then 8,550 minus 4,000 would be 4,550. All right, and then to get x alone, multiply by 1/35, 1 over 35, or divide by 35. That means the same thing. All right, and then I have my x on one side. Sorry about the pushing here, the paper. Then we have 1x on one side equals, and then you can set up long division if you want. 35 goes into 45 one time with 10 left over, and then you drop the 5. 35 would go into 105. 3 times, and it looks like the answer is going to be 130. But you could also punch that in the calculator. 4,550 divided by 35, and yes, like I said, 130. All right. So 4,550, how many times does 35 go into that divided by 35 is 130. Right. And don't forget to check your answer. Now again, you could use a calculator to check it. Go back to the original equation, take 0.35 times 130. All right, 0.35 times 130, I'm just punching that in, that's 45.5. And then 45.5 plus 40 would be indeed 85.5. So yes, this is a good solution to the equation. But again, it's not the answer. All right, it's a word problem. I want to write my answers in full and complete sentences and throw units on my numbers so that they have actual meaning. What does the 130 mean? All right, so remember the question. All right, the question was how many miles, this part D, sorry, how many miles was the truck driven if the rental cost is $85.85. So I'm going to write that there. So the answer to this question is if the rental cost is $85.50, then the truck was driven as we have seen 130, right? That's the value of x that makes the cost 85.50. 130 miles. Remember, this x represented truck, the number of the miles you drove. And this is how I would answer if I was asked this on in an exercise or in a math class. When you're given a word problem, application problem, please answer your questions in full sentences, complete sentences, and put units on your numbers. The 85.50 has dollars units, the 130 has miles units, so that the numbers have actual meaning that makes sense with the problem. Great. All right, so not only that though, okay, not only do I have all this, I also have another point on the graph if I want, right? If I were to look, on the graph of this cost function, right, on the graph of C, we'd have the following ordered pair. X is 130, so remember it's X comma C, it's the input comma output. When X is 130, the cost is 85.50. Right, so I could, now this is not, it's 85 and a half, probably a little difficult to draw on graph paper with decimals, but still, I do have another point I could plot on the graph of this cost function when I get to it in a second here. So now I have 3 points. I have 130, 130 for X, 85.50 for C, and then from the last part, from part C, I have 80 for X, 68 for C, and then for part B, I have the C intercept, right, 0 for X and 40 for C. All right, so now we finally get to part E, where I'm asked to actually graph the function. All right, so I'll write it up again. What was that function? It's still up here, but I'll write it on this page in case I lose it. C of X equals 0.35 times X plus 40. All right, now I've already drawn my axes. Now you don't have to do this on graph paper. But I've got the horizontal axis, again, usually represents the independent variable, the input variable, which is X, and the vertical axis, you could call it the y-axis if you want, but the vertical axis represents the dependent variable, the output variable, which is C, right, the name of the function. Okay. Now I know it's linear, right? It's got that mx plus b form, so I know this is going to be the graph of a line. And to graph a line, you really only need 2 points, right? And we actually have the coordinates of 3. So let me plot some of those. Now, the way I'm going to set this up, I am going to have every value on every square on the x-axis represent 5 units instead of 1 unit, right? So like this is 5 miles driven, this is 10 miles driven, and 15, 20, and so on, okay? And same thing for the vertical axis. All right, now for the vertical axis, I'm also going to have the the vertical axis. I'm going to have each square represent 5 units. All right, so there's $5, all right, $10, $15, 20, 25, 30, 35. Here's $40 right there. Okay, so remember that C-intercept, right, from the part B. Let me plot that. That was the point, and I'll label the points. When x is 0, C, the value of C was 40. So 0 for x and then 40 for C. We're on the C-axis. That was the C-intercept. All right, there's the point 0, 40 that we had from part B earlier. All right. And another point we had was from part C. And I'm going to throw that up here. We had 80, 68. Right, 80, 68. I don't like the 68, right? Because again, I'm having you can eyeball it. I could go 80 on the x and 68 on the y, or on the c axis. Sorry, you can call it the y axis. It's just 68. I'm gonna have to kind of eyeball that. I don't really care for that. But one thing I can do also, I don't need to use those points that I had. I can use the slope. I've put up a video prior to this on graphing a linear function of this form, y equals mx plus b, or c of x equals mx plus b. Where the way I did it was, you graph the y-intercept, or in this case the c-intercept, and then you can use the slope. All right, so the slope here, remember the slope is represented usually by a lowercase m, and that was the coefficient of the x, right? So this guy here, that's the m, the 0.35. All right, 0.35. Which if I write that as a fraction, right, that's, remember that's the hundredths place, the tenths place, the hundredths place. This is 35 over 100. You can leave it like that, or if you want to simplify this fraction, right, what's a common factor that the numerator and denominator have? That'd be, it's 5 times 7 over 5 times 20. That's 7/20ths. If you want to write it that way. But I'm actually going to keep the slope in this form here, the 35 over 100, 35 hundredths, 0.35 like it is, because these are nice multiples of 5, and that's the way I've set up my axes, where every single square is representing 5 units. All right, so in the numerator, you're seeing 35, right? That's the rise, right? The how much you go up or down. And a positive rise, positive 35 means I'm going to be going up 35 units. And then the run, right, the horizontal change, the change in the horizontal value, the independent variable, that's a positive number as well. And a positive run indicates I'm moving to the right. So right 100 units. So this tells me how to get from one point to another point if I wanted to on this line. I can go from a point on the line, I can go up 35 units and then right 100 units. Alright, so let me do that here. Now remember, every single one of these notches, every single square I'm having represent 5 units. So from the point on the line, 0, 40, don't start from the origin, right? This tells me, the slope tells you how to move from a point that's actually on the line to another point. Alright, so I'm going to start from 0, 40, go up 35 units. Now 35 units, that would be 7 of these squares, right? 7 times 5 is 35. So there's 5, 10, 15, 20, 25, 30, 35, right? 1, 2, 3, 4, 5, 6, 7. So up 35 units. That would be from C is 40 to C is 75. So from this point I go up 35 units, and then I go to the right 100. Now 100 is 5 times 20, so that'd be 20 of these squares. So again, let's go, starting, I'm at 0 right now on the x. I'm going right 100, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. There's 100 out there if every square represents 5 units. So I got the ordered pair 175. That, this location up here is another ordered pair. So 75 going over until we're in line with 100 here. That's the location of another point on this line. Right, where the ordered pair is, some nice multiples of 5 for the input and output. There's 100, 75. And again, double check that. Let's double check that. Let's make sure that when x is 100, the output, the C, is actually 75 at 100. Right? Well, when I replace x with 100, 0.35 times 100 would make this 35, and then 35 plus 40 is indeed 75. All right, so now that I have these two, we can draw the line, right? It is a linear function, and I know the graph's going to be a line, and to draw a line, I only need two ordered pairs. You only need to plot 2 points. All right, so I'll pull out my ruler here and try to make this look good, where we got the points lined up, and then starting from 040, drawing it through that 175, and then have it keep going that way forever, because again, we said the domain was all non-negative numbers. Notice I'm not continuing it, because we stated earlier, like I said in part A, that the domain was non-negative numbers. So it wouldn't make sense to have values over here, to have graph over here, because this would be negative miles driven. How can you drive negative miles? It doesn't make sense. So it's going to start here and go that way, and that's it. Great. And now all our other points, right? Let's see if those other points actually are up there. All right, why not? Let's check it out. So I had that one that was 80, 68. Right? Let's see, where would 80 be? That's 100, 95, 90, 85. Here's 80 for the x. And let's see the point that's on the graph here. That's this point right here. So this should be the point 80, 68. Now let's see. Let's see if that point actually has a C coordinate between 65 and 70. So this is 75, this is 70, this would be 65, and look at that, right? This point, right, you see how it is between the 65 and 70 on the C-axis, right, 68. Wonderful. Another point that I mentioned we would have was this point here, 130, 85.5, right, 85.5. So if I went out to 130, this is 105, 110, 115, 120, 125, 130, right, that's just 6 more later. There's 130. And then look at the point that's on the graph here. It's around there. I mean, it looks like it's at a corner, but it's a little bit higher. It should be. This should be 130, 85.5, right? 85.50 from a part D. Let's see. Look at the C-axis. This would be 80, 85, 90, right? And look at that point there is just above the 85 one, just above 85. And it should be 85.50. So this looks good, right? The graph of our line actually has the points we discovered in parts, B, C, and D on it. Great. All right, now that I have this graph up, we can answer one more question. All right, now you don't really need the graph to answer this question, but we're given that function describing the cost of renting the truck, right, for driving it X miles for a day. Part F, this is the last part. How many miles can you drive if you can spend up to $127.50? Alright, so that's not actually going to show up on my graph. $127.50, I'm up to $90 here, then that would be 100, two squares up. So $127.50 is a little bit off the screen there. It's not on my graph. But we can answer this. This is actually no different than part D was. All right, they're saying how many miles can you drive, right? That's X. Find X. X was the miles driven. And if you spend up to 127, so they're saying C can be $127.50. So they're giving me a value of C. and asking for a value of x. Now technically I should say that you can spend up to $127.50. So they're saying the cost C of x, right? This is the cost of driving x miles, can be up to less than or equal to $127.50, right? So we're going to actually solve a little inequality here. You could just solve this equation as well and maybe use the graph to determine you can drive so many miles, but I'll solve this inequality. All right, so what was the cost of driving x miles? What was the value of driving x miles? That was this. That was again 0.35 times x plus 40, and we're saying that that has to be up to, can't cost any more than, so less than or equal to 127.50. All right. Okay, and I'll do the same stuff where we take this entire left side. I'm going to multiply by 100 to get rid of the decimals, move all the decimal points to the right 2 places. So I take the entire left side, 0.35x plus 40, and that's going to get multiplied by 100. And there will be some distributing because there are 2 terms over there. Each of those terms will be multiplied by 100. And since I'm multiplying, I might look at other videos on solving inequalities. When you multiply both sides of an inequality by a positive number, which I'm doing here, the direction of the inequality symbol does not change, so it still is less than or equal to. So this side will be is less than or equal to, and then over here I have 127.50, right? And that will also be multiplied by 100. I'm doing the same thing to both sides. The left side, when I multiply the first term by 100, that's making that 35, positive 35x, plus, and then 100 times 40 is again 4,000, like we saw on an earlier page. And this needs to be less than or equal to, it needs to be up to, and then 12,750. Right, that's moving the decimal place to the right twice, times 100. That's 12,750. All right. Then we gather all the terms without the variable on one side, terms with the variable on the other side. So the 35x will stay over here, and I'll just subtract 4,000. Right, get rid of this 4,000. Now, another thing about inequalities, again, if you want to look up other videos on solving inequalities, there's some properties you'll come across where, when you add or subtract the same thing to both sides of an inequality, the direction of the inequality still doesn't change. So we still have 35x on the left, and then that still is less than or equal to, same direction the whole way through so far. And then 12,750 minus 4,000 would be 8,750. All right. Okay, and then we're going to divide by 35 to get x alone, and just like with multiplication, if you divide by a positive number, which I'm doing here, I'm dividing both sides by positive 35, again, the direction of the inequality does not change. So we still have x, 1x over here, and still is less than or equal to the same direction the whole time. I haven't done anything to change the direction of the inequality. In fact, I think the only thing you're going to have to remember really is that if you multiply or divide both sides by a negative number, that will flip the inequality's direction, flip the symbol, make it is less than and is greater than. But we haven't done that yet. And then 8,750 divided by 35. Again, you can set up long division, say 35 goes into 87 twice, right, making 70, and then you subtract that from 87, you got 17, drop the 5. Then 35 goes into 175 5 times, so it looks like 150 would be the answer here. Or you can, I'm going to punch it in as well just to double check that it actually is 250. I did say it goes into 87 twice, didn't I? So problem with doing things in your head. So yeah, set up a long division thing, use a calculator, but this 8,750 divided by 35 is 250. All right. So there, and again check, and you can check back on the original. Does 250 make these equal? Is 0.35 times 250? So I take 0.35 times 250, That's 87.5, and then is 87.5 plus 40 equal to 127.5? Yeah, so this is working out. 250 is good. But again, that's not the answer. Right? I want to answer my questions and word problems in full sentences. All right, so my answer here is, how many miles can you drive if you can spend up to $127.50? I'll say if you can spend up to $127.50, then you could drive that truck up to 250 miles, is what this is saying right here. The number of miles I can drive is up to, at most, 250. And that is how I would answer this question, if I was given it as an exercise and a math in a math homework. Full sentences, numbers have units attached to them, so they have meaning. All right. And if I were to go back to the graph too, this is just telling me that if I went all the way out to, say, again, it's not going to be on this graph here, but if I went on the x-axis all the way out to 250, then the point would have a y coordinate or a c coordinate of this $127.50, right? And then everything under 250, right? Every mileage under 250 has a cost less than that, right? So you can, if you only had $127.50 to spend and you decide to rent this truck, you look in your account, you only have $127.50 that you can put on this card or something. Then you say, oh, I need this truck, but I can only drive it up to this many miles, because after that, then you wouldn't be able to afford it. You'd be over your balance. All right. So I hope a lot of that made sense. Again, just one application, one word problem there, where the use where a linear function was put into use. And then, I had a lot of stuff covered there. When am I given an input? When do I calculate an output? What is the domain of the function? And remember, domain has to mean something to the problem. You have to take it in context. What is it? What is an intercept? How do I graph a linear function? Right, lots of stuff came up in this video. All right, and as I like to say at the end of these, try your best, do the best you can to learn the material, understand the material on your own before you go looking for help. I find material tends to stick with people better for longer if they took the time and the effort to learn it on their own. So read the material, read the author's examples, perhaps even try to work out the solutions to an author's examples before you read how the author did it, and then compare your work to the author's and see if you can learn from mistakes that way, or learn by comparison. Work on practice problems and exercises, of course. Look up solutions when they're made available to check yourself and see how you're doing. And don't just give up after the first attempt, right? Don't be so easily frustrated. If after several attempts, though, several approaches at a problem, you're still not working out, it's still not clicking in your head, then perhaps you should read through the material again. Maybe more slowly, more deliberately. Take some good notes. Maybe even a third time, because who knows, if after having worked through some problems, you'll have a better understanding as to what's being asked for. So then reading back through the material, you'll know what to look for. Maybe you'll see something the second or third read through that you didn't see the first time. Something will click the second or third read through that didn't click the first time. But if after that, if after several read-throughs of the material and several attempts at problems, approaches at problems, you're still not getting it, well then, it is not a sign of weakness whatsoever to go asking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in the class who knows the material and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos on the subject, such as this one. Or, again, there are loads of videos out there that are plenty better than this one. I assure you, you can find them. But just keep at it. Stay persistent. Keep practicing. And try to have a positive attitude as well. You'd be amazed at just a difference and a change in attitude can make. Don't go in thinking you're going to hate it right away, because then you're probably just going to keep hating it, and it's going to make the learning experience terrible. Go in with an open mind, thinking I'm going to learn something today. I'm going to enjoy doing this. I'm going to have fun with it. I'm going to take something away from this, and it's amazing. It's amazing the difference that can make. So stay positive, keep practicing, stay persistent, don't give up, and I just know you can get it eventually. And thank you for watching.